Hello students, welcome to AriserTalent. Today we are going to start mathematics of class 10th. So let's have the overview of syllabus. The very first chapter of your book is real number and the second one is polynomial. The third one is pair of linear equations in two variables. Then quadratic equations. The fifth one is arithmetic progression, then triangles and coordinate geometry. The next chapter, eighth one is introduction to trigonometry and then its applications. Next one is circle and then its construction and area related to circles. The next chapter is surface area and volumes and then statistics, and the last chapter is probability. Students, the good news is these chapters are the ones we have studied in class 9. So, what's the difference? In these particular chapters, like in real numbers, which is an advanced part of number system, okay, polynomial, quadratic equation, which is an advanced version of linear equation, and you have also studied circle, construction, area related to circles, surface area, statistics, probability. You studied it earlier, but in 10th standard, there is some upgradation in your syllabus of these topics. Okay, so what we are going to do, we will study some basics of class 9 to make sure that our base is sound for this subject, right? So, we will study real number, very first chapter of mathematics today. Real numbers. Before going into real numbers, first let me recall you number set you have studied in class 9th, 8th and even in 7th. Number system. Students, we always have a system to understand anything. Now, mathematics is all about numbers. So, basically, we divided these numbers systematically in number system division. So, we are having mainly two numbers, two type of numbers. One is real number and the second one is which is not real, that is imaginary number. In this chapter and in particular this class, we will only talk about real numbers. So, what is real number? What is real? I can touch it, I can see it, so it is real. In normal talking terms, it is real because I can touch it and I can see it. So, what is imaginary or what is not real? That I can't see, that I can't feel, that I can't touch is unreal. In mathematics term, student, the real numbers are the line, in mathematics, the real numbers are the numbers which we can represent in number line. Now, what is number line? We are having a line here. This number line. So, now we will study some definite sets, some number sets, and we will mark these number on this number line. So, first set is natural set, which is denoted by n. Natural numbers. N. The set n is nothing but our counting numbers 1, 2, 3, 4, 5 and so on. Now, put a 0 in this. Just put a 0 in this. Now, the set will become 0, 1, 2, 3, 4, 5, isn't it? And so on. This number, this set of number is known as what? Right, whole numbers. So, I am going to represent these on this. 0 is the midpoint of this number line. This is our number line. And 1, 2, 3, 4. On the right hand side, I am counting these. 1, 2, 3, 4, 5 and so on. Now the left side is remaining and here it comes. We are having another set. These are positives. We all have negatives with positives. So, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5 and so on. Looks familiar? This particular set of numbers is known as integers. Okay, and on the number line, we represent it like this: -1, -2, -3, -4, -5 and so on. So these are integers. Okay, note it down. Okay, now we are having some space between 0 and 1 and 0 and -1. So, there are some numbers that are remaining after studying these all sets? Yes, of course. Look at this. Is this a number or not? This is a number. But do we have studied these numbers in previous sets? No. Is this a number? Yes. Is this a number? Yes. Is this a number? Again, yes. And is this a number? Again, yes. So, we are going to study these numbers further. Other than these sets, we have rational number. Remembering something from your previous classes? Rational numbers. What are rational numbers? Rational numbers are the numbers which can be written in the form of P by Q, where Q must not be equals to 0. This is the condition. In the form of P by Q, where Q must not be equals to 0. Have an example here, like 1 by 2, like 3 by 2 and many more numbers here. Okay, these rational number also having some divisions here. Some rational numbers terminates while some rational number do not terminates. Terminating and non-terminating. Let me explain this in one more. Let me explain this term again. What is terminating? If I am taking 1 by 2 as expression as my rational number, so how I solve this? I'll be having 5 here. So the value of 1 by 2 is simple, 0.5. Okay. Now, if I take a fraction like this, 10 by 3. Now solve this, students, with me. 10, 3 times 9 minus, we'll put a decimal here, again 9, 3 times, again 1, and this process is not terminating. This will occur again and again. So, this is terminating and this is non-terminating. But reoccurring. Okay, so we are having two kinds of rational numbers. One is terminating or recurring, and second one is non-terminating and recurring. Okay, now again some sets are also here like pi. If we calculate the value of pi, it will never terminate. Okay, so it is non-terminating. We are having root 2, root 3 values. Okay, these values not only doesn't terminate but also doesn't reoccur. So there are some values which are non-terminating and non-reoccurring. So, irrational numbers are the numbers which are non-terminating and non-reoccurring. Okay, like the value 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and so on. This is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4 and so on. The value doesn't terminate anywhere and there is nothing like a pattern that reoccurs. So what is it? It is irrational number. Irrational number cannot be written in the form of P by Q. Okay. So I hope your number part is now finished and you understand it well. So we will move to the next part which is important, Euclid's division lemma. Now let me first clear you. So now the next topic is Euclid's division lemma. Now first let me clear you what is the meaning of lemma. Lemma is basically an already proven, mind my words, already proven statement which is used to prove other statements. Now a bit confusing. Okay, let me explain you with an example. Like you were late in your school, so you said something to your teacher, your ma'am, that I was late in school because of this and this reason. Now what your ma'am will what will your ma'am do? She'll just call your mother and ask her so the next topic is Euclid's division lemma. Now what is lemma? Lemma is nothing but an already proven statement which is used to prove other statements. Now little bit confusing. Okay, we will explain it with an example, a daily routine example. If you are late in school and your ma'am asks, why are you late, why are you so late, and you will say something to her that because of particular this reason I am late. So now your ma'am will call your parent, your mother, and ask her that whether your statement was correct or not. Now your mother's statement is like a lemma, because whatever your mother will say to your man will be considered as already proven statement that it is the correct situation. So whether you told your ma'am is correct or not, is right or wrong, will be considered as per your mother's statement. So your mother's statement is lemma, right? I'm explaining this word to you in this way because we are having another word, algorithm, in this particular chapter, and it is very important to distinguish between lemma and algorithm. So now you can understand what is lemma, an already proven statement like your mother's statement for you, because your statement is going to judge by your mother's statement, because what she was telling to your teacher is absolutely right. Okay. Now, what is Euclid's division lemma? It's very simple. We have done division a lot of time, a lot. Okay. So, what we are going to do? We are going to do it again. And very simple one. 56 by 5. Here 56. Here 5. What we call it? Dividend. This is divisor. 1 time 5 minus 0. Here we will have 6. Then 1 time 5. Remainder 1. Now how we used to write it? We used to write it like 56 equals to 5 multiplied by 11 plus 1. This is how we used to check it. Now, this particular equation is nothing but Euclid's division lemma. Okay. These are two integers a and b, and this is our quotient and this is our remainder. You can see the same expression in Euclid's division lemma, which is here. Now see. BQ plus R. Okay, now this R, value of this R can be equals to 0 or greater than 0, but never can be equals to B or greater than B. Understood? So, for any two given positive integers A and B, there exist unique whole numbers Q and R. This is Q and this is R, where R will lies between 0 equals to 0 or greater than 0 and obviously less than B. This is your dividend. This is your divisor, and you know this quotient, and this is remainder, right? So now why we are studying this one? What is the use of division lemma? What is the use of division lemma? First, because it is a lemma, it is an already proven statement, we will use it to prove another statement. That's the first use, and the second use is we can find HCF. Now you know what is HCF. This is highest common factor. We have studied it in earlier classes, okay, but we will discuss an example here, so don't worry. So, moving forward, HCF. of 200, sorry, HCF of 100 and 210. How we used to calculate it? This is a simple method. We will do the prime factorization of 100 and 210. Okay. Now, what is prime factorization? We have seen prime numbers. Prime numbers are basically the numbers that can be having factors only as 1 or itself. Okay. But 1 is not a prime number. Like if we are having 1, 2, 3, 4, 5, 6 and so on, 7, let me take 7 and 8 also. So, I've told you 1 is not a prime number. Now 2. 2 has factor 2 and 1. 2 and 1 multiple. Okay. So, first factor is 1. Second is itself. Now, any third factor is here? No. So, it is a prime number. 3. 3 into 1. Any other factor possible? No. It is a prime number. 4. 2 into 2 into 1. So, here we have 2 into 2 into 1 as its factor, and 1 into 4 is also a factor of this. So, other than 1 and itself, it is also having a factor of 2. So, it is not prime. Same, this is a prime number, this is not a prime number, this is a prime number, and this is not a prime number. So, basically the prime factorization are 2, 3, 5, 7 and so on. You can find it easily. So, we will do the prime factorization of both. Now, prime factorization of 100 will be 2 into 2 into 5 into 5. Right. This is the prime factorization of 100. Okay. If you can't do this like this, you can also do it like this. 50 multiplied by 2, then 2 into 25 multiplied by 2. Now 2 into 2 and 25 is 5 multiplied by 5. So this is the prime factorization of 100. Now 210, simply 2, 1, 0 and 5. Yes. Then 2 into 5 into 2 and 1. Then 2 into 5 into 7 into 3. Oh, we will write in order 2 into 3 into 5 into 7. Now, what are the common factors? 2 is here, again 2 is here. So, 2 is common. Now, again we are having any 2 here? No, we are not having any 2. Then 5, yes, we are having one 5 here. Okay. Now, again 5, no. Again 7, no. So, 2 into 5, 2 and 5 we are having as prime factorization. So, we will get 10. So, HCF of 200 and HCF of 100 and 210 is nothing but 10, right? Now, Euclid's division algorithm. Now, I have told you that we will study two terms here, first lemma and second algorithm. The second one is here. Now, in first case, your mom helped you out. Okay. In second case, your mom is out of town and you want to eat Maggie. So, you decided to cook Maggie for you. Now, the problem is you want to eat Maggie. And what the solution of this, what is the solution of this? You will follow a step-by-step procedure. You will burn the gas. Okay, you will put some utensil, put some water on it, and you will then do this recipe thing, and step-by-step procedure you will get your final solution that your Maggi is prepared and you can eat that. Okay. So what was the question? What was the problem that you wanted to eat Maggi and what was the solution at the end? You ate Maggi. But the process was step by step. This process is nothing but algorithm in terms of mathematics, right? So an algorithm is a series, mark my word, a series of well-defined steps which gives a procedure for solving a type of problem. You were having a problem in mathematics, we will having many problems, but we will solve it very easily with the help of Euclid's division algorithm, right? Now, we will discuss the questions of or examples and theorems of Euclid's division lemma and Euclid's division algorithm. In next session is next chapter. Keep watching. Thank you.